Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're with us. I'm Steve,
And I'm Scott.
and together we're Backyard Musings Science and Technology Channel.
Yeah, we're talking about a health issue this morning and some AI involved with that health issue. So
Yeah,
here we
AI
go.
is being used for much good. Let me tell you,
Yeah.
the medical field is exploiting AI, which is really cool. New research explores how hidden patterns in the human voice could serve as early indicators of disease. Cancer of the larynx, often called the voice box, remains a major global health concern in 2021. About 1.1 million people were diagnosed worldwide, and roughly 100,000 died from the disease. Smoking, heavy alcohol use, and infection with human papillomavirus are key risk factors. Survival rates vary widely, ranging from 35 to 78% over 5 years with treatment. Even with the treatment, it's you can die. I mean, you get particle of food in there because you got like a breathing tube or whatever, and you get food in there, then now you got pneumonia. One of the guys from my ward in Granite Hills, he developed this, and I was his minister, and I just watched him waste away to like from like 170 down to 70, and he eventually died.
I've known a couple of people that have had this type of cancer. One of the people that I know did pass away, and the other one, yeah, it takes a lot out of you.
It does. So with that 35 to 78%, it depends on where the tumor develops and how advanced it is at diagnosis. Would you like to know more?
Okay, early detection plays a critical role in improving outcomes. Today, diagnosis typically relies on video, nasal, endoscopy, and tissue biopsies, which are invasive and can be difficult to access quickly. Delays in seeing a specialist may slow diagnosis and treatment.
New research published in Frontiers in Digital Health, June 25th, 2025, last year, suggests a different approach. Scientists found that subtle changes in a person's voice can reveal abnormalities in the vocal folds. These vocal fold lesions may be harmless, such as nodules or polyps, but they can also signal early stage laryngeal cancer. The findings point to a potential new use for artificial intelligence, identifying early warning signs of cancer through voice analysis.
Interesting. Quote, here we show that what this data set we could use vocal biomarkers to distinguish voices from patients with vocal fold lesions from those without such lesions. And this is according to Dr. Philip Jenkins, a postdoctoral fellow in clinical informatics at Oregon Health and Science University, and the study's corresponding author.
Jenkins and his team are part of the Bridge to AI Voice project within the U.S. National Institutes of Health's Bridge to Artificial Intelligence, Bridge to AI consortium. This nationwide effort aims to apply AI to complex biomedical problems. For this study, the researchers examined tone, pitch, volume, and clarity using the first public release of the Bridge to AI voice dataset, which includes 12,523 recordings from 306 patients across North America.
Only a portion of these recordings came from people with diagnosed laryngeal cancer, benign vocal fold lesions, or other voice disorders such as spasmodic dysphonia. Is that what that is?
Mm-hmm.
And unilateral vocal fold paralysis.
I would think that you'd have to give a sample of your voice before any of this took place so that it can compare before to now, right?
Sure. Again, obviously something's wrong with you, right? So you go to see your family doctor, your general practitioner, or whatever, and then they refer you. So yeah, I don't know. Maybe I don't know how they do that. Maybe it's gradual. I don't know, but interesting.
The team analyzed several measurable features of speech. These included mean fundamental frequency or pitch, along with jitter, which reflects small variations in pitch, and shimmer, which captures changes in amplitude. They also measured the harmonic to noise ratio, which compares structured sound to background noise in speech.
Clear differences emerged in the harmonic to noise ratio and pitch among men without voice disorders, men with benign lesions, and men with laryngeal cancer. Similar patterns were not identified in women. That's interesting. Although the researchers note that a larger data set may reveal meaningful trends.
The study suggests that changes in the harmonic to noise ratio may help track how vocal fold lesions develop and could support early detection of laryngeal cancer, particularly in men. Quote, our results suggest that ethically sourced large multi-institutional data sets like bridge to AI voice could soon help make our voice a practical biomarker for cancer risk in clinical care, said Jenkins.
With these initial results in place, the next step is to apply the algorithms to larger data sets and evaluate their performance in clinical settings. Quote, to move from this study to an AI tool that recognizes vocal fold lesions, we would train models using an even larger data set of voice recordings labeled by professionals. We then need to test the system to make sure it works equally well for women and men. And that's according to Dr. Jenkins.
Yeah, it sounds like it's still in development.
Yeah.
Sounds a little bit complicated too. So continuing his quote, voice-based health tools are already being piloted. Building on our findings, I estimate that with larger data sets and clinical validation, similar tools to detect vocal fold lesions might enter pilot testing in the next couple of years, predicted Jenkins. That's good.
Yeah. I mean, a couple of years sounds like a long time, but I guess not. You know, when it comes to this kind of stuff, they got to make it right, you know. But yeah, this sounds very promising.
Yeah. We'll see. We'll keep you updated.
Yep. Keep after this one. So,
all right, folks. Thanks for joining us. We'll catch you this afternoon.
Take care, everyone. Thanks.